In this chapter, we're going to be looking at advanced uses of functions. And in this first lesson, we're going to begin looking at one advanced use of functions, and that's the recursive function. Not so much an advanced use as it is an advanced technique for writing functions. So let's get started. We're going to call this program recursive1.py. And we're going to start to explain recursion by demonstrating how to use recursion to compute the factorial of a number. The first thing we have to understand is that recursion can naturally explain how recursion occurs. So what I'm going to do is I'm going to start with some comments here and give you an example. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Another way to look at 5 factorial is to see that it's equal to 5 times 4 factorial. And then we can say 5 factorial is equal to 5 times 4 times 3 factorial. And clearly this is a recursive definition. Let's take this last example out. Now here we're defining recursion in terms of itself by saying that 5 factorial is equal to 5 times 4 factorial, which is the same thing as saying 5 times 4 times 3 factorial, and so on. So clearly factorial has a recursive definition that we can use. And in fact, that's the more natural way to describe how to compute factorial. We did it an iterative way earlier because those are the only tools that we understood at the time, was how to use a loop to compute factorial. So let's see in this lesson how to write the factorial function using recursion. So we'll begin the definition the same way we did before, def fact, and then our parameter will be number. First thing we have to do is we have to say if number is less than or equal to 1, return 1. And I'm going to come back and explain all this in a moment. First, let's go ahead and finish the definition and execute the function. Then I'll come back and explain how the recursion actually works. So we say if number less than or equal to 1, return 1, else return number times factorial number minus 1. So this is the recursive definition right here. Here we're saying if the number is greater than 1, then return the number times factorial of 1 less than the current number. So if we start out at 5, we're going to say return 5 times factorial 4. And what happens is as we build up these returns, what we'll see is we'll see essentially this pattern. We'll have a 5, and then a 4, and then a 3, and then a 2, and then a 1. When we get to the point where we're out of numbers to compute, then we work backwards and perform the multiplications. 2 times 1 is 2, 2 times 3 is 6, 6 times 4 is 24, 24 times 5 is 120, and that is the factorial of 5. We can demonstrate how that works by writing print fact 5. Let's save and run the program. We'll leave it open because we're going to use it again. And we see that 5 factorial is indeed 120. Let's try it with a different value. Let's try 10, just to do a larger one. 3,628,800 is the value of 10 factorial. So again, to look at the definition, the recursive step occurs right here, where we call factorial with a new input. Just like in a for loop, we have to keep decreasing the variable in order to eventually stop the program. If we didn't do that, then we'd run out of memory at some point and the program would crash. But that's how recursion works. And what happens is we're just delaying the eventual computation by continually calling the function again with a smaller input. So that the first time it's 5 times 4 factorial. Then it's 5 times 4 times 3 factorial. Then it's 5 times 4 times 3 times 2 factorial. Then finally we get to where it's 5 times 4 times 3 times 2 times 1 factorial. 1 factorial is 1. That will cause the function to stop. And then the term we use is unwind. Then we unwind all of these products to get the eventual value of 120. So that's how recursion works. And with that, we're ready to move to the next lesson where we're going to look at a couple more examples of using recursion in a Python function.